The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. Okay, so today we're going to start the last chapter. Chapter 11, and we're going to look at section 11.1. So here we go. Let's say we had the following function. F of x equals 2x plus 3. And we also had another function, g of x equals x minus 7. All right. Let's review how you go about evaluating functions. Let's say that we wanted to evaluate f of x equals 2x plus 3 when x is 7. So we'd say when x equals 7. So we go f of 7 equals 2 times 7 plus 3, which is 14 plus 3, which is 17. So we'd say f of x equals 2x plus 3 equals 17 when x is 7. Any questions about that? All right. How about when x equals, let's say, 3x? So then we'd say f of 3x equals 2 times 3x plus 3. Which would be 6x plus 3, right? Because whatever goes in here goes in the place of x, right? Any questions there? Okay.
Nope.
What about this? Let's see if I can get rid of the red. Okay, here. What about when x equals x minus 7? So in other words, f of x minus 7. What would you do there? You'd put x minus 7 in the place of x, right? So you'd get that. Everybody okay with that? Which would
Yes.
be 2x minus 14 plus 3, or 2x minus 11. Okay, what if instead of all that, I wanted to evaluate f of g of x? Well, what is g of x? It's x plus 7. So wouldn't that be f of x minus 7? I said x plus 7, my bad. X minus 7, which would be 2 times x minus 7 plus 3. In fact, that's the one we just did, isn't it? Okay. So what am I doing? I'm evaluating f at g. Well, there's an operation that's called composition. Composition. And just like addition, subtraction, multiplication, and division have symbols, the symbol for composition is a circle. Okay. So let's say that we want to use composition on f of x and g of x. We want f composed with g of x. Okay, that's how we would write it. And I know it looks like fog, but it's not. So f composed with g of x. What does that mean? That means we're going to evaluate f at g of x, which is basically what we just got through doing. So f composed with g of x would be f of g of x, which is x minus 7, which would be 2 times the quantity x minus 7 plus 3, which is 2x minus 14 plus 3, which is 2x minus 11. So f composed with g of x equals 2x minus 11. Now, what we're doing isn't difficult. It really isn't anything new, but it's doing things in the correct order, knowing what this means, that this means to do this, which means to do this, et cetera, et cetera. Okay. So here we go. Let's take a look at a bunch more of examples. Let's say that f of x equals 2x plus 1. And g of x equals x squared minus 1. Okay. We want to find f composed with g of 2. Now, in the example I did earlier, we had a general case. Here we're looking at a specific case where we've got an actual number instead of some expression. Okay, algebraic expression. So what does f composed with g of 2 mean? That means we're going to evaluate f at g of 2. So I need to know what g of 2 is equal to. G of 2 equals 3. So that's going to go in the place of g of 2. So now we want f of 3. Well, that's going to go in here. So that's going to be 2 times 3 plus 1, which is 6 plus 1, which is 7. So f composed with g of 2 equals 7. Now, again, each little piece is not anything new, but knowing what to do and when to do it and when to make the substitutions, that's the tricky part. Any questions on this particular example before we look at other examples? Okay, let's go back to f of x equals 2x plus 1. And g of x equals x squared minus 1. Now let's find g composed with f of 2. So we've switched the order. Instead of doing f composed with g of 2, we'll do g composed with f of 2. That's equal to g of f of 2. Well, what is f of 2? F of 2 is 2 times 2 plus 1, which is 4 plus 1, which is 5, using that. So 5 goes in the place of f of 2. So now I get g of 5, which is, that's going to go up here, 5 squared minus 1, 25 minus 1, 24. So g composed with f of 2 is 24. Notice that we don't get the same answer. So composition is not commutative in general. F composed with G does not always equal G composed with F. Now I said does not always. There are some cases where it does. We'll be looking at those tomorrow. But in general, composition is not a commutative operation. Okay. Let's take a look at another example. Again, we're going to use the same f of x equals 2x plus 1. And g of x equals x squared minus 1. Now let's find g composed with f of negative 3. So g composed with f of negative 3 equals g of f of negative 3. So putting that up here, what is f of negative 3? That's 2 times negative 3 plus 1, negative 6 plus 1, -5. Then that's going to go in here. So that gives us g of -5. But that's going to go in here. So we get -5, the quantity squared minus 1. 25 minus 1 is 24. So G composed with F of -3 equals 24. All right, getting the idea? How about, let's see here. Let's take a look at some new functions. F of x equals 3x minus 2, and g of x equals x squared plus x. Find each of the following. F composed with g of 4. So, F composed with g of 4. So F composed with g of 4 equals F of g of 4. G of 4 equals 4 squared plus 4, which is 16, plus 4, which is 20. So 20 goes in the place of g of 4. So F of g of 4 is F of 20. And that goes in here. So that's going to be 3 times 20 minus 2. 60 minus 2 is 58. So F composed with g of 4 equals 58. Any questions? Okay. Let's take the same two functions again. F of x equals 3x minus 2. G of x equals x squared plus x. Let's find F composed with g of x. Well, F composed with g of x equals F of g of x. But g of x is x squared plus x, so that's going to go in there. So that's equal to F of x squared plus x. But then that's going to go up there. So that's equal to 3 times the quantity x squared plus x minus 2, which is 3x squared plus 3x minus 2. So F composed with g of x equals 3x squared plus 3x minus 2.
Can we do another one like that?
Sure. Let's do this one. Let's see. X minus 2, and g of x is x squared plus x. Instead of doing f composed with g of x, let's do g composed with f of x. So we're going to evaluate g at f. G composed with f of x equals g of f of x. But what is f of x? It's 3x minus 2. So g of f of x would be g of 3x minus 2. But how would you find g of 3x minus 2? You'd put that in there. So that's going to be 3x minus 2, the quantity squared, plus 3x minus 2, because that goes every place that x is. So this is going to be 3x minus 2 times 3x minus 2 plus 3x minus 2, which is 9x squared minus 6x plus 4 plus 3x minus 2, which is 9x squared, minus 12 plus 3 is minus 9x, plus 4 minus 2 is plus 2. So that equals that. Did I lose you there?
No.
Again, it's not, each little piece isn't difficult. It's knowing what to do, what each piece means. Okay, how about this one? Let f of x equal 1 over x and g of x equals 1 over x squared. Okay. Let's find g composed with f of 1/3. Okay. So g composed with f of 1/3. So that's equal to g of f of 1/3. F of 1/3, we're going to put 1/3 right there. Let's see, if we put 1/3 right there, f of 1/3 would be 1 over 1/3, which is 1 divided by 1/3, which is 1 times 3 over 1, which is 3. So that equals 3. So that's going to go in here. So that gives us g of 3, because f of 1/3 was 3. G of 3 is going to be 1 over 3 squared, which is 1/9. So g composed with f of 1/3 equals 1/9. You okay with that?
Do another one similar to this one, please?
Let's see here. Let's do this one. Again, f of x equals 1 over x. G of x equals 1 over x squared. Let's find g composed with f of 1/10. So g composed with f of 1/10 equals g of f of 1/10. So I need to figure out what f of 1/10 is. So we're going to take 1/10 and put it up in there. F of 1/10 is 1 over x, but x is 1/10. So 1 divided by 1/10, which is 1 divided by 1/10, which is 1 times the reciprocal, 10 over 1, which is 10. So f of 1/10 is 10. So this is going to replace all of that. So our next step is g of 10. But how do I find g of 10? Well, g of 10 is 1 over 10 squared, which is 1 over 100. So g composed with f of 1/10 is 1 over 100. Let me know when you're ready to go on to another example.
Ready.
Okay. Another one. Again, let's take f of x equals 1 over x and g of x equals 1 over x squared. And let's find g composed with f of 8x. So we're going to be replacing x with 8x. So g composed with f of 8x equals g of f of 8x. All right. Now, what is f of 8x? Well, that would be 1 over 8x, right? Because wherever x is, you replace it with 8x. So f of 8x is 1 over 8x. So g of f of 8x would be g of 1 over 8x. So this, let's see here, this replaces all of that. But now we're going to put that in there and in there. So that's going to be 1 over 8x, the quantity squared, which is 1 over 1 squared over 8x squared. So 1 squared is 1, 8 squared is 64, and x squared is x squared. But that's 1 divided by 1 over 64x squared, which is 1 times 64x squared over 1, which is 64x squared. So g composed with f of 8x equals 64x squared. We okay with this one?
Yes.
All right. Let h of t equal the square root of t plus 3 and k of t equal t minus 5. Find h composed with k of 18. So h composed with k of 18 equals h of k of 18. But k of 18 is 18 minus 5, which is 13. So that's going to go in the place of k of 18. So h of k of 18 is h of 13. And that's going to go there and go there, which is going to be the square root of 13 plus 3, which is the square root of 16, which is 4. Pause briefly while I sneeze. Okay. So h composed with k of 18 equals 4. You okay with that?
Yes.
All right. Let's use the same two functions again. H of t equals the square root of t plus 3. K of t equals t minus 5. And let's find k composed with h of -2. So k composed with h of -2 is k of h of -2. H of -2 is the square root of -2 plus 3, which is the square root of 1, which is 1. So 1 goes in the place of h of -2. So now we have k of 1. And that goes up here. So that's 1 minus 5, which is -4. So k composed with h of -2 is -4. We okay there?
Yes.
All right. Now, I said earlier, I had us look at a couple of examples, and I said that in general, composition is not commutative. We're going to show this in another way. Let's see here. We're going to take f of x equals x plus 1, and g of x equals 2x minus 5. We are going to show that f composed with g of x does not equal g composed with f of x. Okay, so show. So we're going to take f composed with g of x, get the result, g composed with f of x, get the result, and show that they're not equal, which will show that composition is not commutative. Because if there's one example that doesn't work, then you'd say, oh, it's not commutative in general. All right, so f composed with g of x equals f of g of x equals f of 2x minus 5 equals 2x minus 5 plus 1, which is 2x minus 4. Now that I've done all that, let's go back through it a little slower. Okay, so f composed with g of x is f of g of x. But g of x is 2x minus 5. So that's going to go in the place of this, which is where it is right there. Then f of 2x minus 5, 2x minus 5 is going to go there, which means it's going to go in the place of x, and then plus 1. So we get that. Okay, so f composed with g of x is 2x minus 4. Any questions about that part? Okay. Now, let's take g composed, g composed with f of x. Well, that's equal to g of f of x, which is g of x plus 1, which is 2 times x plus 1 minus 5, which is 2x plus 2 minus 5, which is 2x minus 3. And again, let's go back slower. F or g composed with f of x is g of f of x. But f of x is x plus 1. So that goes in the place of f of x here. Then we take g of x, but we evaluated it at x plus 1. So that goes there. 2 times x plus 1 minus 5, 2x plus 2 minus 5, 2x minus 3. And notice that these are not equal. So composition is not commutative in general. Tomorrow, we'll look at a special case where it is commutative, but that's tomorrow. All right. Any questions before we go?
No, not on my part.
All righty. Well, have a great rest of the day, and I will see you all later. I'll be back at 1:15 with an office hour, and otherwise I'll see you tomorrow.